So learning outcome 1 is to carry out calculations using these equations of motion, as we call them. Strictly speaking, there are a couple more, but they'll be ones that you'll be already familiar with. D equals V bar T, S equals V bar T. The derivation of these is not required to be memorised, even though I go over it in class. It just avoids them kind of appearing out of thin air. And basically, for a learning outcome like that, carry out calculations, all we do is list the equations, list all the variables, what they mean, and talk a wee bit about the problem solving methods. So first of all, the variables, and you can list them in any order you want, but you might find it a wee bit easier to remember this nonsense phrase, suave T. So S, remember, is displacement, measured in meters. U is initial velocity, measured in meters per second. A is acceleration, measured in meters per second squared. Final velocity and time in seconds. So these are the various things that we can measure about something that's accelerating. Remember the V bar, if we're being precise, over the right hand side here, is average velocity or average speed in the case of the first one. So remember D is distance. But in general we will be dealing with displacement and velocities. Now it says quite clearly though that you'll be dealing with these in one dimension, but possibly including change of direction. So the one dimension simply means that we only need to worry about something going, say, left or right, up and down. Okay, we're not yet looking at two-dimensional motion. And the change in direction then is simply represented by positive and negative numbers. Now, you could, for every problem, decide what's going to be positive, what's going to be negative. But when we get to that bit, I'll discuss, I think it's better to get into good habits and a regular habit of doing it. And the other thing I would say about general problem solving method is to list, as soon as you recognise that this is something that's accelerating, list this suave T, write down what you know, and then remember you need to know at least 3 before you can solve to find the other 2 using these equations of motion on the left hand side anyway. And then really for this carry out calculations, the only other thing we can do in terms of a learning outcome note is to look at worked examples. That's the best way. So I've got the ones out the notes copied and I'm just going to go through the solutions for them. So a body moving with a velocity of 30 meters per second undergoes an acceleration of 5 meters per second squared in the same direction for 6 seconds. Calculate the displacement and the velocity during that 6 seconds. So my standard problem solving technique, suave T, and then start writing down what I know. So the body was moving with a velocity of 30. So that's at the start of the motion that we're interested in. It then undergoes an acceleration. And everything in these first 2 examples is in the same direction. And the time is 6 seconds. And then in part A, we're being asked the displacement, and in part B, the velocity. So for part A, if we look at U, A and T, you can flick back to the previous page if you want. But the equation which links U, A and T with S is S equals UT plus a half AT squared. So substitute. Don't do any rearranging algebraically. Substitute in what you know, 30 times 6 plus a half times 5, and remember to show your substitution. Don't go straight to an answer in your head of what 6 squared is. That's your second mark, remember, in a standard 3 marker. So formula, substitution, and then just working out the rest. So 180 plus a half times 5 times 6 is 18 times 5 is 90. Sorry, you can use a calculator, of course. So we'll get S, that's the displacement during 6 seconds. Then when we get to B, we now have a choice because we now know 4 out of 5. But as we discussed in class, you would always go with the simplest one. Right, so that's this one in this case. So you would substitute into that. V equals 30 plus 5 times 6. 30 plus 30. So the velocity after 6 seconds is 60 metres per second. So fairly straightforward one to start us off. Same idea here. Suave T. What do we know? The train is travelling at 45 metres per second at the start of the motion that we're interested in. It decelerates to 15 metres per second. So its final velocity is 15. But watch, this word decelerates goes with that. So the acceleration isn't 2, because that would increase the velocity each second. We can see here the velocity is going from 45 down to 15. So we use the decelerate bit to get that's minus 2. And we're being asked how far it travels. There's more than one way of doing this, but the simplest way, you've got the 3 things that you know, and you're being asked S. The one formula which can link those together is V squared equals U squared plus 2AS. Okay, so you could work out T, then work out S, but that's giving you more work, more chances to make careless mistakes. So there's 1 mark for formula. You wouldn't get any extra marks for doing it that way. So substituting is your second mark. And the plus 2 times minus 2 times S. So 15 squared is 225. 45 squared 2025, and the 2 times minus 2 becomes minus 4s. And then it's just the arithmetic now. I'll put in all the steps. I'll add 4s to each side. 225 plus 4s. You may jump some of these steps depending how comfortable you are with arithmetic. Take away 225 from each side. And then S is 1800 divided by 4. Yes, 450 metres. Okay, so remember your marks, formula, substitution, final answer in units. Next one, we start to take account of the idea of a change in direction. So ball is thrown vertically into the air with initial velocity of 20 metres per second. What will its velocity be after 3 seconds? So the key thing about when you start to think about changing directions is you have to be very careful with the signs of objects. What's positive, what's negative. So the initial velocity is 20. And the standard convention, as it's called, that we're going to use is always take upwards to be positive, downwards to be negative. Okay, it's just much easier to get used to always working that way so you don't get mixed up. So the initial velocity is 20 metres per second, and that's upward, so that's positive. The velocity is 3 seconds, and that's the only numbers you're given in the question. You're going to have to substitute some yourself. And what you should remember is that free fall, so objects which are dropped with no other forces acting on them, we're neglecting air resistance. In an actual past paper question, it would make clear to neglect air resistance, but we'll just assume that's the case. But what we can fill in is for dropped objects, the acceleration is minus 9.8 metres per second squared. It's 9.8 down the way. So that's why the negative. Now, if you don't have U being positive and A being negative, or at least being the opposite sign of each other, that counts as wrong physics. Okay, so you're not going to get any marks past the formula. Now that's really important that you get that right. And we're being asked the velocity. So the formula now that links these together is v equals u plus at. So v is 20 plus minus 9.8 times 3. Okay, or 20 minus 9.8 times 3, it's the same thing. So that's 20 minus 29.4. So the final answer you get is minus 9.4 metres per second, or 9.4 metres per second downwards, i.e. the stone has gone past its highest point and started coming back down again in those 3 seconds. So in this one we don't appear to have much information at all in the question, but if we recognise that this is going to be accelerating due to gravity because it's dropped, so we can fill in the t equals 3 seconds, we can fill in the a is minus 9.8 metres per second squared because it's in free fall, and we can use the fact that it was dropped to fill in 0. So remember, you can only use these equations of motion if you know 3 of the variables. We're being asked how deep, right, which is linked to the displacement. We'll see why I say linked in a wee second. So the formula here would be S equals ut plus a half at squared. S equals 0 times 3 plus a half times minus 9.8 times 3 squared. Remember, show that substitution as 3 squared. Don't go straight to 9 just in case you make a careless mistake. The other careless mistake to watch out for in these ones is 0 times 3 is 0, not 3. And calculate that. It's minus 44.1. So S is minus 44.1 metres, and now hopefully you'll see why I say the height is how deep as the well is linked. This displacement is negative because the stone, right, the displacement of the stone is negative because the stone has ended up below where it started. That's what that negative sign tells us. It has a downwards displacement. But the question of how deep the well is, you wouldn't normally have a negative sign in front of that. So the depth, the well is 44.1 metres deep because the stone fell 44.1 metres going down the well. And then last one, we've got quite a complicated question. I'm going to try and split it into 2 bits, because if you look at the question, you have stuff about the helicopter and you've got stuff about the parcel. Okay, so various bits and pieces. So I'll deal with the first 3, although it says helicopter, then parcel. We'll see in a second that they're actually linked together. So I'll try and get the first 3 on this page. If not, I'll need to take a fresh page, but we'll go with that. So for the helicopter, I'm going to do suave T. I've got 2 objects, that's why I'm making a bit of space here. And the parcel, I'm going to do suave T. Just about fitting in. So a helicopter, its initial hovering above the ground, starts to accelerate upwards at 2 metres per second squared. So the acceleration of the helicopter is 2 metres per second squared. After 3 seconds, so that's after 3 seconds of the helicopter accelerating, so that applies to that. A parcel is dropped, which takes 6 seconds to hit the ground. So what do we know about the parcel? We know it had 6 seconds to drop. And that's all the numbers now filled in from the question. But we've got a few wordy bits. So the helicopter was initially hovering. Tells us its initial velocity was 0. And the parcel is dropped. Now, what that means if the parcel's getting carried by the helicopter, its initial velocity isn't zero. It would be if the person dropping the parcel was standing still, but they're on a moving helicopter. So that's why we need to do part A first. So we need to get what speed the helicopter was going at when the parcel was dropped, because that's the speed the parcel will be at. That's its initial speed as well. And the other thing that we can fill in before we go any further, the helicopter's not in free fall, but the parcel is. So we can fill in it for the parcel. A is minus 9.8. So now for part A, speed of the helicopter. So I'm being asked V. So I've got U, A and T, so I can simply use V equals U plus AT equals 0 plus 2 times 3. So the speed of the helicopter at that instant is 6 meters per second. And that becomes the U for the parcel, because the helicopter's carrying the parcel. So in part B, the speed of the parcel before it hits the ground is asking us the final speed. I know once it hits the ground it might end up at rest, but that's when other forces come into play. We can only use the A as minus 9.8 while it's actually a projectile, while it's in free fall. As soon as it hits the ground, that changes. So we can only work out the speed it actually hits the ground at, not what happens afterwards. Or at least this part of the course, we'll go into later to deal with those sorts of ideas. So for part B, I'm being asked V. So I can do V equals U plus AT again, but different values here of U and A and T. So 6 plus minus 9.8. Right, so the initial speed of 6 for the parcel came from the part A, and the time for the parcel was also 6. Okay, so it's just calculator out and I can get the speed of the parcel. Is minus 52.8 meters per second, or 52.8 meters per second. That's what that minus means. You can just leave the minus in if you want. You can write it downwards, kind of being double safe. So now we know the speed of the parcel the instant before at the ground. I've solved for the velocity rather than the speed, so the speed is simply 52.8. And then the displacement of the parcel when it hits the ground. So there's our part C. So once again I've got a choice, probably the easiest formula that we've not used yet anyway. S equals a half U plus V times T. So a half 6 plus minus 52.8. So I do need the velocity here rather than the speed. And the time is also 6. So plug all that into your calculator. So S is minus 140.4 meters. And you can put in the word downwards as well. So that's the displacement of the parcel and it hits the ground. And once again it's negative because the parcel has ended up below where it started. So that's what that negative sign tells us. And then we've been asked the height of the helicopter the instant the parcel is dropped, the maximum height reached by the parcel. I'll carry them on to the next page. So for part D, height of the helicopter, well actually that's quite straightforward. If the parcel fell 140.4 meters, then the helicopter must have been 140.4 meters high. Now, for EE, we're being asked about a different part of the motion for the parcel. So I know we'd previously had a set of variables listed, but we're now being asked about from the maximum height. There's more than one way to do this problem. I know the notes have got a different way, but I think this is a good way to approach it. And that is if we do our suave T, this time we say U is 0, because that's what happens at the maximum height. The maximum height is the point where it changes from having a positive velocity to a negative velocity, and 0 is a number when velocities change from positive to negative. Okay, so the velocity is 0 at that instant, it doesn't stay at 0. Right, it will soon change because the acceleration is still minus 9.8. Okay, but at that instant. So we can fill in the acceleration. We'd worked out previously that it hits the ground at minus 52.8. And we're being asked the displacement for that. So we can use the equation v squared equals u squared plus 2as minus 52.8 squared equals 0 squared plus 2 times minus 9.8 times s. So if you substitute in and calculate, so we'll do a wee bit of calculation as we go through it. I'm going to keep all my significant figures in the middle of a calculation, never round off during the middle. Now, if I divide both sides by minus 19.6, I am going to end up with a negative answer. And once again, that's not surprising. Okay, I'll write out all my digits. And then I'm just going to round that to 3 significant figures. So displacement is minus 142 metres, i.e. the highest point is 142.2 metres. Okay.